This is a walkthrough of Problem 2 on Exam 1 of Module 11 in the book Problem Solving Guide for Electromagnetism and Optics. An object is placed 40 centimeters from a curved mirror. The image of the object is projected onto a screen that is 120 centimeters from the mirror. What is the focal length of the mirror? Draw a neat ray diagram that shows the correct position, orientation, and magnification of the image. Indicate the focal length on the diagram and label the object and the image. The problem says the mirror is curved, but it doesn't say whether it's converging or diverging. We have to get that before we do anything. We can't even draw a diagram because we don't know which way the mirror is curved. The second sentence reveals the image is projected onto a screen. It must be a real image. Diverging mirrors can never produce a real image because a diverging mirror doesn't focus the light. The mirror must be converging. Now we can start and draw a diagram. So there's our converging mirror. There's our object, BW coffee mug. It would be nice to have the focal length because then we know where to draw the ray. We have the object distance plus 40. The image distance is plus 120. It's a real image. We can use the thin lens equation. Plug it in 40 centimeters for P, 120 centimeters for Q. Writing 40 as 3 over 120 to get a common denominator. We get 4 over 120, which is 1 over 30, which means the focal length is 30 centimeters. So we have a focal length of 30 centimeters, which is inside the position of the object. So that focal length is 3/4 of the distance to the object. Now we can start drawing rays in parallel out through the focal point. Then center of the mirror reflects. Angle of incidence is equal to the angle of reflection. And they meet somewhere down here, and that is the position of the top of the image. There it is. We should expect a big image because the image is 3 times as far away from the lens as the object. So the image should be about 3 times as big. So to answer the question, the focal length is 30 centimeters. And there is our ray diagram. We should add the labels. There is the object, and there is the image. That's problem 2.